right, ladies and gentlemen, so today's our last lesson from chapter 7, and today we're going to be talking about something called the sphere. And a sphere is basically, it's a three-dimensional shape where all points are the same distance from the center. Right, we call these really kind of balls, but not like a football, more of a basketball shape, right? So it's going to be, you have your center, and then every single point around it is going to be the same distance, which is called your radius. So it's taking a circle, and instead of just going around once, you can go around any way at all. A hemisphere is half of a sphere, and I know you use that hemisphere word in social studies when you're talking about the world and the globe and maps. You'll use it in earth science when you take that at the high school eventually when you're talking about weather and stuff. So there you go. Hemisphere is half of a sphere because our earth is pretty much is very close to a sphere. Anyway, my formula. So because it is circular, we're still going to be using our pi. This time, though, we have 4/3 pi r cubed is our formula, right? So this isn't a big B type problem. There is no flat surface. There is no base. So the thing we have to make sure is that you have to have radius. So must have r. They give you a diameter. You have to cut it in half. So let's just get right into it. It's the same process we've been working on. So we start with our formula. Volume equals... Start with our formula, and then I wrote it wrong. 4/3 pi r cubed. The directions are telling me to round to the nearest tenth. And we're going to use our pi button again because it didn't tell me otherwise. And my radius is 6. So 4/3 times pi times 6 cubed. So I'm going to put that into my calculator. Let's see, 4/3 pi 6 cubed. It's going to give me 904.8 millimeters cubed. Okay, so for number 2, we have, this time they gave us a diameter, so I need the radius, which is 11. So formula, 4/3 pi r cubed, fill in my numbers, times 11 cubed. Put it in my calculator to get the correct answer if I enter everything correctly. And I'm going to round that answer to the nearest tenth. So 5,575.3 centimeters cubed. Okay, number 3, same thing. This time they gave me a radius. So volume equals 4/3 pi r cubed. Fill in my numbers. Radius is 5. Put it in my calculator. Now, for those of you that are using your phone as a calculator, in order to do the 4/3, you would multiply by 4 and divide by 3. So 523.6 millimeters cubed. All right, let's see what we got over here. Now we have, these are hemispheres. So I'm going to need half of my answer. So I can go through and do the half as I go. So I'm going to have half times 4/3 pi r cubed. All right, I have a radius, so that's all right. So I'm going to have half times 4/3 times pi times 5 cubed. If you want to do the 4/3 pi r cubed and then take half of your answer, that is certainly okay to do. Times pi times 5 cubed. So 8,000, oops, hold on, sorry. I missed a button. Sorry about that. times 4/3 pi. Okay, that makes more sense. 261.8 centimeters cubed. All right, and number 5, this time I have a diameter, so I need my radius, which is 1. Again, it's a hemisphere, so I need half. So half 4/3 pi r cubed. Fill in my numbers. Pi times 1 cubed. So we're going to have half times 4/3 times pi times 1 cubed. And we're going to get 2.1 centimeters cubed. Okay, a spherical stone in the courtyard of the National Museum of Costa Rica has a diameter of about 8 feet. I need a radius. I know that, so I'm going to do that right away. Find the volume of the stone round to the nearest tenth. So it's a spherical, it's not a hemisphere, it's not half of it, so it's our regular 4/3 pi r cubed. So then we're going to have 4/3 pi and 4 cubed. Oops. Put that all into my calculator. It does tell me to round to the nearest tenth. So again, we have to make sure that we're always following our directions. Times 4 cubed. So 268.1 feet. Yep, feet cubed. Okay, hopefully not too hard there. A volleyball has a diameter of 10. So again, right away I'm going to say that the radius is 5. A pump can inflate the ball at a rate of 325 cubic inches per minute. How long will it take to inflate the ball? So first I have to find the volume. So a volleyball is a sphere, 4/3 pi r cubed. So we're going to have 4/3 pi, oops, and my radius is 5. So my volume of the volleyball is 523.6 inches cubed. Now, I know that it can be inflated at 3.25 cubic inches per minute. So to find out how many minutes, now I'm going to have to take and divide. 523.6 divided by how fast it's being inflated. So let's see, divided by 325. So I'm getting 1.6 minutes, because again, it said to round to the nearest tenth. So taking what we know about unit rates now and using it in conjunction with our volume work. And then a snowball has a diameter of 6, so again, I'm going to write radius right away. How long will it take the snowball to melt if it melts at a rate of 1.8 cubic centimeters per minute? Same idea. This time we have to find the volume and then divide by the 1.8, but instead of getting bigger, it's actually getting smaller. So 4/3 pi r cubed. So 4/3 pi times 3 cubed. 4/3 times pi times 3 cubed gives me a volume of 113.1 centimeters cubed. Now I have to figure out how long it's going to take. So I'm going to take that 113.1 divided by the 1.8, because that's the rate that it's melting at. So divide by 1.8, and it would take 62.8 minutes. So a little bit over an hour for that ice cube to go ahead and melt. So again, hopefully nothing too complicated here. If you can do formula, number, answer, label, you should be fine. It's just knowing which formula to use when and making sure you have the radius. Any questions, as always, bring them to class. Have a good night.